Chances are, if you're into 3D printing, you've probably seen those sick looking time lapses on YouTube before. Something like this. Scott Ujan seems to have mastered this beyond belief, so let's see if I can do the same. This print's been going for 7 hours. And with a time lapse you'll see later. There seems to be two kinds of time lapses you can do. One is rather easy and the other one takes a bit more equipment. And actually there's even a third one which kind of tops them all off. Let's start with the easy solution. First though, I need to figure out how to make a 3D time lapse. Because if you just set up your camera, film the print and speed up the footage, the result you get is really not what you're after and it doesn't look that great. Check this out. So, how do we actually make a nice time lapse? We basically have to get a camera, set up on a tripod, and figure out a way for it to trigger a picture every time the layer is finished. It sounds really simple. Lucky for us, Cura has a post-processing script that allows us to set up the printer so that it stops every layer and moves out of the way. However, I'm not going to be taking a picture myself manually every time the layer is printed. So, here's the plan. I'm going to rig up a remote trigger to the side of my printer so that the print head can go and press the trigger every time a layer is printed. I stripped down an old wired DSLR trigger so I can add a tiny button to the side of the printer. I glued, yes glued, a tiny bolt to the head so you can reach the button. It's not pretty, but it should work. So let's try and print something and see how it goes. Okay, so that worked much better than I thought. It's only a static time lapse. I'm pretty sure if I want to add movement to the shot, I'm going to need to use a motorized slider, but there is an issue with that. So I'm going to hop online and see if I can buy one, and I'll try and figure out the issue later. What? I thought I could buy one, but they're way too expensive. So I'm actually going to try and build it instead. Okay, so here's a list of the things I'm going to need to build this slider, which is motorized, by the way. I need a tiny stepper motor, a timing belt, a rail, a sliding camera stand, and a couple timing pulleys. Listing them like this makes it sound so much more complicated than what I thought. So the main two parts I'm actually going to need to figure out myself are a stand that the camera can sit on. I've prototyped one here, and a slider which can hold the camera and act as the rail. Here's the beginning of one. I'm using wood because that's what I just had laying around. I'm not sure why I didn't simply go with a linear bearing system. Instead, I thought I could rotate the bearings 45 degrees so that when on the rail, they kind of just rest on it and I can then just simply remove it when I want to and transport it around. I'll need to add a few extra 3D prints, including some brackets to hold the wood together, a motor holder, and I've got 4 stands to keep the rail up. Sounds super easy. Everything's set up. I'm now just going to plug it in and see if it works. All right, so you actually seem to be sliding right now, and I think everything is working pretty well. It's perfect for prototype. I can see my 3D prints out of PLA as slightly fragile and not super strong, but as a proof of concept, it is working. Lucky for me, Just Away has decided to support this project and offer their printing services to help me print some reinforced parts that my printer can't do. So I went over to their website, uploaded my STLs and selected the glass fiber reinforced nylon, which seemed to be the best choice for a project like this. The parts look awesome and definitely help the whole slider feel much more stable. So a big thank you to Just Away for supporting this project. I've added a link to their website in the description for you to check out. So after some testing, it seems like the slider can move from A to B in about 5 or 6 minutes, which is really awesome for any sort of traveling shots. But unfortunately that won't do it for a time lapse. I could simply add an extra gear to change the ratios, but I think the torque might be a small issue for the motor. I'm also slowly seeing an issue with this whole setup. The fact that the slider is going at constant speed, but the layers are being taken at different timings, since each layer of a 3D print could take different times. So my solution for this is trying to rig up an extra button on my 3D printer that will turn on and off the slider every time the layer is printed. So the slider will only move a few centimeters every time the picture needs to be taken and then stay static when the layer is being printed. I have absolutely zero info on my tiny motor. The listing has vanished from AliExpress since buying it, but I'm going to assume the red wire is the one I want to cut and rig up to the printer. My aim here is to have the motor powered and use the 3D printer head to bridge the switch every time it triggers to move the motor. Okay, so here's where I'm at. I cut the red wire, turns out that was the right one. I did some connectors to each end so I can use a momentary and or a maintain button depending on the situation. And after some testing, it seems to work exactly like I want it to do. So I'll 3D print a box to fit all the mess in and set up a momentary switch somewhere on my ender 3 near the camera trigger so both can be hit at the same time. This is beyond goofy looking. We've got a camera rigged up to the slider, slider's rigged up to the printer, printer head presses the buttons that triggers the shutter and the motor to start off for a few centimeters every layer. There's no denying that looked awful, but I did learn a lot from it. The sliders are going too fast, so I'm running out of space because as soon as it hits one end, it goes to the other side. The script needs some tweaking because there's too much stringing, or whatever it's called, between every layer, so the prints are actually getting degraded, which is not the goal at all. And the buttons are being held with sellotape, which is a dumb idea for something that's going up and down in constant movement. So I'm going to 3D print a bracket to hold both buttons and a trigger that's a bit more solid, and we'll go from there. Well, that second attempt looked 100 times better than the first one. However, there's still a few things I could be tweaking, such as filming and printing in the night, or at least with shutters and blinds closed. As you can see, the light from outside is making the whole time lapse look super stuttery because the brightness is changing a lot. And one more thing, the motor keeps dying out because the speed was too slow for the weight of the camera. So my two options are either speeding up the motor so it can constantly pull the camera, or putting a lighter camera with a lighter lens. We're almost there and it's looking really good. Well, it seems all I needed to do was shoot in the dark and give enough power to my motor to move the camera in one smooth motion. The results seem really good for now, but I did mention one more thing you could do to make it even better. I've used it in 2 of the time lapses in this video. I'm not sure if you noticed, but I'll show you right now what you can do to take it even a bit further. All right, so I'm editing this video in Davinci Resolve, but you can do this in After Effects as well. All you need to do is, once the time lapse is done, don't move your camera, set it in video mode and film yourself picking up the object that you just 3D printed. After that, mask your hand until it touches the object, overlap the masked hand on your time lapse and then cut to the video when you're holding the object. Match both footages and you've got yourself a hand going in normal speed in the time lapse. I hope you enjoyed this video. It was super fun to make and really useful as well. And I will see you next time. Take care.